So my name is Charles, but you can call me Charles if you can't pronounce that. I work for a company called Streamroot. I lead the product organization there, but I'm actually an engineer, so this is not going to be a product pitch, don't worry. I'm joined today by my friend and colleague Jean-Baptiste Louazel, who is our lead integration engineer. Today we're going to talk about automating integration tests and all of the challenges that these bring in the video space. But before we do that, let me just give you a little bit of context on who we are for those of you who don't know us. So we are a company that provides client-side video delivery optimization. Our first and main product is a solution that enables hybrid peer-to-peer and CDN delivery. But we had quite a lot of success with it, so we've also created two other products, mainly a midstream CDN switcher and eCDN for corporate streaming. We are working with a lot of broadcasters all over the world with a lot of different use cases, and we are powering around 25 million video sessions every day. And last bit of news, we were recently acquired by CenturyLink, and our offer is now an integrated part of their media delivery services to expand the capabilities of their global CDN. Now that this is out of the way, let's get back to our main topic. Last year, for those of you who remember, we presented our data-driven approach to improve QoS with limited amount of resources. This year, we want to focus on what happens before production and answer the question, how to gain confidence that you won't break playback for anybody with this latest build that you're about to ship. Because we all know it in this room, whether you're a broadcaster or a vendor, breaking playback sucks big time. So moving on. I'm hoping that some of you are already thinking that, well, with all of the tools that we have today, alerting, monitoring, canary release, and quick rollback, you don't necessarily need that much confidence when you're releasing. And you'd be right to think that. And you should definitely use those tools whenever you can if you're not already doing it. But I want to ask, could that ever be enough? Could we imagine a deployment platform super advanced that allows us to really just need to deploy automatically on a small increment of users? Whenever we detect some playback regression, it would automatically roll back. Let's imagine that we have this. Could we ever get rid of the need to actually do integration testing? I doubt it. It's a hard question to answer because I don't have this super theoretical platform in front of me, but I doubt it. And one of the reasons is that in the video space, we have so many moving parts playing together to enable playback that there is not one entity that actually controls the entire deployment of the video workflow. Think about it. If you're broadcasters, a lot of the code that's actually enabling playback for your users, you don't have the upper hand on it. And it's even worse for vendors because usually broadcasters will ask you to send them your release ahead of their scheduled deployment so that they can deploy your code and test it ahead of time, obviously. So even if you were controlling the entire deployment, there's also the scary thought to think about, the scary possibilities that what if the code that you're releasing is going to break this canary alerting deployment system that you have in place? What are you going to answer to all of the angry tweets? Are you just going to send a screenshot of your monitoring tool saying that, look, it's working? What are you talking about? So for now, we should keep thinking about Canary and all of these tools as a fail-safe, especially in the video space, and not as our primary playback regression detector. And you're going to have to do what needs to be done, and that is testing ahead of time your code, ahead of release, in the same environments as your viewers, of course. Which brings me to my next question. How many different environments are we actually talking about here? So just for the sake of getting to an actual number, I will pick a random example. Let's assume you were a peer-to-peer video delivery company. The question you have to ask yourself is, what are all of the important dimensions that can affect my behavior, and what's the cardinality of all of these dimensions? Well, we support 3 streaming formats with 2 media engines, with around 10 versions for each of them in production. We support 15 players, again with around 10 versions for each of them in production. We have 3 operating systems. We have 5 different browsers. And I'm going to stop here for a second just to be polite, but this list goes on and on and on. If you start to add all of the configurations, CDN configuration, player configuration, SSAI, you name it. And so just with this little lower bound list, we already get more than 100,000 combinations of use cases to tackle. So at this point, if you're a reasonable person, you should start feeling the heat a little bit, and you should start to think that we're going to need to automate a lot of that. That's good, but that's not it. There's one little extra piece of coolness, I would say, that we get in the video space, which is that testing for video playback is fickle, and it's not deterministic. What does that mean? Well, we have a lot of different components, some sitting on the client, on the back end, the network, all of them playing together to enable playback. And they all kind of have unreliable timing. And so you're going to have a hard time in your integration tests to test for everything that you would want on playback. Also, I hope that the idea of bundling the entire video pipeline in some sort of containerized ecosystem, or even just a significant portion of the video pipeline in it, to make it more deterministic, I hope that you know that this is going to raise a million more problems that it's actually going to solve. So we didn't go that route. And so what does it mean in practice, this non-deterministic aspect of our testing? Well, when you're going to test, you're going to get a lot of false positive and false negative. You absolutely do not want to go down the rabbit hole of false positive, because imagine living in a world where whenever your test is telling you that it's actually working, you have to doubt that it's actually working. That's a horrifying thought to me as well, so we don't want to go there. So you're going to have to be very defensive when you write your test against the false positive. The cost of that will usually be to leave more room for false negative. But those you can actually pretty much tackle with some human help. So basically, every time there is a failure, you're going to need somebody to check that there is actually a failure, and it's not just something that happened for a weird reason, and that the failure was caused by your code. Okay, now we get a pretty good vision of all of the problems we're going to need to tackle, but we are here to give you solutions, not just these problems. So let me break down the capabilities that you're going to need to put in place to tackle all of this. First, we're going to need a way to generate environments where we control all of the configuration variables, especially the static ones. Second, we're going to need a way to know all of the available versions of the other components we're interacting with, and again, be able to spin them up in our control environment. Third, we're going to need a way to simulate basic user behavior. Why? Because it's nice if autoplay is working, but if when you seek it's crashing, you still kind of broke playback. So we're definitely going to need a basic user behavior simulation to make sure that everything is working fine. Fourth, we're going to need for a way to assert for a few basic things. Of course, playback, that's in the title of this talk, but not just. You guys all know here that for properly servicing all of your users, you're going to need a bit more than just testing for playback. 5, we're going to need a way to orchestrate all of these tests on different browsers and operating systems. That's fairly obvious, I guess. And 6, because of the non-deterministic aspect of our testing, we're going to need, for every test that we do, especially the failed ones, we're going to need to get a full view of what happened during the test so that a human can go in there and actually say, yes, this is a problem, we need to fix something there. So, quick spoiler, we have all of these capabilities today at StreamRoot with some limitation, but we'll get to that. And as you can probably guess, we didn't build that overnight. So I'm going to let Jean-Baptiste tell you all about the solutions that we put in place to tackle all of these problems.
Thank you. Hello, everyone. So obviously, we didn't build everything in one tool. So let's take a look at what it took. Here is a list of all the components that were needed to be able to make those requirements a reality. But let's start with the beginning. We needed, at first, the simplest possible setup, which is basically creating a page and testing the associated parameters. And before we built our automated testing solutions, here is how it looked like to launch a QA at StreamRoot back in the days. So it begins with a simple request from your QA team to test a component that has just been released, whether it's ours or not. So you would happily get along with the task of spinning up the right testing environment. And in practice, what does that mean? That means to create an HTML page with everything inside that you would upload somewhere. You do that, all is good, and you provide that to your QA team so they can test. And their answer will actually be like that they need a bunch of other stuff to test. And the typical developer reaction to that be like, the point of this story is that it was time-consuming to provide a working testing environment, and that we often needed more than one. And introducing our solution to solve this situation, the Forge. So the idea behind the Forge was to fasten the creation of test pages and making this process doable by anyone in the team. The UI you are seeing here is constituted of 3 main parts. So the first one is the player configuration panel. It will allow us to select a player among all of those we support, to target a specific version of it, and to even add configuration on top of them. That we got the panel about the rest of the configuration of the page, which stream to run, will there be peer-to-peer or not, which backend URL should you put, everything related to that. And finally, we get to the pre-visualization/action panel. We can see the code moving live as soon as we touch the configuration of the scenario. Et voila, we generated our test pages. But you see, we didn't really like to store everything every time we were actually generating a page. So we added an extra bit, which is the ability to fully encode a test page within an URL that would facilitate the page management while making Forge interfaceable with other components. But we'll get to that later. In a nutshell, Forge is a web service created in React that would do various things for us. It will fetch the version from various sources of all the components we need, and by actually storing everything in its URL, it will be able to call its templating engine that will consume that to generate the final page. And here we have fulfilled our 2 first requirements. We now have a way to quickly create test pages and to manipulate all the configurations that are attached to the page. And now we want to be able to test user behavior and to do assertions on top of it on various environments. So we're going to need to build those 3 tools now. And to do that, we use Selenium. According to their website, Selenium automates browsers. Well, that looked promising. So we tried it to see if it was adapted to a video use case. And put simply, a Selenium client will run locally on your computer. That's where your tests will be written. And when executing them, they will be sent to a node. The very first test we wanted to do was to provoke a visible impact on a player across multiple browsers. So we started with a very simple use case, playback. But we also wanted to assert that this action in our code would actually mean something. So we needed also a way to check that the playback effectively started to do. And to do so, a simple function like that will do the trick. So simple function that checks the player and returns a Boolean so the client will understand it. And now that we have a way of provoking an action on the node, on the player, and to test if it works, we can start to add more complexity to that into a scenario. And we use Jasmine to power that, which is one of the available JavaScript frameworks out there. This one is really simple. We play the video, then we wait for 30 seconds. We do the assertion with the function we have been creating. And if these tests actually pass, that would mean that we are now able to execute functions on the player. We are now able to control the player and to also assert that the player responded well to our controls. So if we can do that, we can now start to extend our scenarios and start actually accumulating user behaviors. But you see right here, we only got one player, which is unfortunate. And with a little bit of abstraction, we can start adding more of them and ensuring actually our tests stay generic and that they will be run everywhere all the time in the same way. So we reach the state of having one node with multiple browsers on it, on which we can test all the players we want. But that's not enough. What we do want as well is to be able to test on various operating systems. So that will mean here multiple nodes. And we are in luck, because Selenium do come with a hub that allows us to orchestrate tests between nodes. So let's just add them. And if we stop here a little bit, we were now at this step able to assert that one of our versions would not break the playback across players, browsers, and operating system. That's already good. But we all here in this room have more complex use cases than just playback. You might also want to test other parts of your workflow, such as your analytics, GRMs, or ads. Unfortunately, Selenium doesn't have a built-in way to do that. We would need actually to search for things that are not inside of the browsers, like requests. And Selenium actually doesn't have the visibility on that. Everything that goes out of the browser is gone, and gone forever. There is no way to tell Selenium, get me this request that has been done in the past. That's actually why we had to put Selenium on steroids. So usually, if you want to intercept HTTP requests in a browser, you would overload the API that do so. If you do that, that means like you are able to actually catch everything and store them in order to give it back to the Selenium client later. But in order to make sure to catch all the requests, that would mean we should do that as the first action of the page. Otherwise, we could just lose early requests. So you're going to say, JB, just tell your client actually to do that at first. But we also have to consider that even if we do inject it from the client at first, that the page will be loaded before, which will make actually our overload potentially miss some requests. So let's try another approach here. What if instead of giving the node the forge page to load, we give him instead a reachable server that will know where to get the forge page from within its request, and will ensure actually our overload is done always at first, which will look like the following. Here we can see that actually our server modified the incoming page from Forge to put our script at first, which will ensure actually we will never miss any request that comes in, and that our test actually can be done in the right way right now. To sum up, Selenium is useful here, but it has not been necessarily built to handle the complexity of use cases, such as the video one. So we had extended it to take account things other than playback. So if you want to use it, keep in mind those limitations. This is just one way of doing it. There might be other SaaS solutions that can work out of the box as well. Let's take another look at our requirement right now. So We now have a completely configurable page generator that is also being able to be consumed by our Selenium setup, which will simulate user behaviors. And by extending it, we were also able to test things that were happening behind the scene. And the last step is that we want to see what happened in the node and have a complete vision of everything. So we're going to need to build a test reporter on top of what Selenium provides at the end. So we are going to give humanity the visibility it deserves. And as I mentioned quickly a bit earlier, we are using Jasmine because we anticipated our needs of human-readable output. Jasmine can create reports in various ways. So we plugged in a reporter called Allure that is able to output clean HTML page with easily actionables on it. And here is simply what one of our reports looks like. It gives a good overview of what happened in a node. And here we can see that something went wrong. And going into details, we can see that we were able to also put some attachment to it, such as screenshots, various logs, or in our case, everything that went through HTTP requests. So having this data aggregated in one place allows for much easier troubleshooting. It pinpoints exactly where and how the test failed. And it seems like we actually fulfill all of our requirements. So what I do propose now is that we take a look at how it looks like from our offices.
Hello again, this is Charles from the Paris office, and I'm giving you a little tour of our integration portal and how we do it every day. We're going to start with what usually starts everything around this office, and that is a commit. So Tree here has a commit ready on one of our core libraries. So he will push it on his branch, and when this happens, you can expect what's going to be happening next. We're going to get a build being scheduled on our CI. Yep. So the build is now running. And so, of course, the CI process will do all of the normal things that the CI process does, checking for linting, testing all of the unit tests, making sure all of that passes, a few basic checks. Of course, attribute different bits build for all of the platform we want to test. And the interesting bit, which is going to happen in this space, which is basically our little QA world where we use it to run various type of tests. But what's going to be interesting for us today is those 4 screens where you can see we have a macOS, a Linux, and a Windows. And normally the build that we output should any seconds now fire the automated integration tests. And there they are. So we see all of those platforms are popping up windows on different browsers. And they're all going to run a scenario of testing with some assertions. And if we just look at one of them here, so we see that the player is by himself seeking forward, pausing the video. It's going to seek forward again, play again, and we do this. So this is all based on a scenario that we wrote in advance. And of course, we're going to assert for very basic things, such as making sure the playback is happening correctly, making sure that the peer connections are happening correctly, the video peer-to-peer exchanges are happening, all of that. And so all of those little tests will basically record what happened during their session, and they will send their reports to our integration test platform. And our integration test platform will be able to aggregate all of those reports together to give us a nice overview of the tests. And if we look back to Tree's laptop, we can see that we get a nice little report. So in this case, we get 18% of our assertion that succeeded. If we look at one of the failure, it's nice because we'll get plenty of context. So of course, we'll get the error and the stack trace, but then you'll also get screenshot at the end of the test. So when the assertion failed, probably all around every 10 seconds during the test, we get a screenshot, and then we get a lot of context. So all of the console logs, all of the XHR. We also get captured all of the WebSocket messages, all of the WebRTC messages. All of this is basically compiled for each assertion that we are testing. And it's great because once we have all of this context, we can super easily create a ticket. A developer can pick it up and spend his time fixing things instead of looking for bugs. And typically in this scenario, he will have all of the context he needs to figure out where the problem is coming from, what happened during the session, and it will be super nice and easy to fix the bug. So I think it's now time for question and answers. Thank you for watching. Hold on. Just before we move to question and answer, I want to tell you a little bit about where we are here today with our platform and what we are working on, because it helped us getting a lot of confidence without needing to hire a full army of interns, but it still carries a few limitations. Namely, and I hope you're thinking about that, native, so iOS, Android, what are we doing with this? Well, the list of requirements that we put up is actually the same. You're going to need to build the same tools. We are working on this. We are halfway through the requirements. We get less tools like Selenium that are available out of the shelf to help us do that, so we have to put more dev effort into it, but it's on the way. Hopefully we can talk about it next year. Today, that was one of the components that was on JB's diagram that we didn't talk about. We don't today automatically schedule tests on external releases, even though we'd like to. Typically, when there is a new HLS.js, whether we're compatible with it or not, we want to know as soon as possible so that we can take the proper actions. We can't assert across different sessions yet, but that's fairly easy to tackle, and it's super useful for us in the peer-to-peer use case. We have a few in-house streams that we rely on, but for all of the advanced use case, we need broadcasters and partner streams, which is a bit not very comfortable, and we'd like to be able to do that ourselves. And finally, which is one of my dreams, is to be able to get a full in real-time compatibility metrics that get updated by our integration test platform, such as whenever we detect a failure, bam, the whole pre-sales team is aware, everybody is aware, and we just have to simply communicate this internally without having to manually fill the compatibility metrics. One little shout out to our awesome colleague who could not come here today. He's not a cat, that's just his GitHub picture. It's not a cat, but he put a lot of effort in this platform, and thank you for all the awesome work. 3 questions now.